this posted problem, let's look at a slightly easier specific example. Let's say you have 3 men, 4 women, and you want to choose a committee of 3 people. And you want to know what is the probability that the committee will have exactly 2 men and 1 woman. Well, when you're calculating probability, the denominator is the total number of possible outcomes. So if we have 7 items, 7 people, and we're going to take 3 of them, 3 at a time, there's a symbol for that. It's called the combination of 7 things taken 3 at a time. We'll talk about how to calculate that in a second, but what I did here was by brute force, I listed all the possibilities. What are the total possible number of outcomes? So you could say ABC, ABD, ABE, ABF, ABG. Those are all the possible combinations or committees where the first 2 are A, B. And then we do AC paired with D, E, F, and G. And then we do AD and so on. And so there's 15 of those where we start with the letter A. If we then go to the committees that start with the letter B, we've got 10 of them. And for the letter C, we've got 6 of them. For the letter D, we've got 3 of them. And for the letter E, we only have 1 of those. And if you add all those numbers together, you get 35. That's the denominator. Now, I've kind of checked in red the committees that have 2 men and 1 woman. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the probability is 12 over 35. Now, how do we actually calculate a combination of 7 things taken 3 at a time? Well, there's a complicated formula. If we have a combination of n things taken r at a time, it's n factorial over n minus r factorial divided by r factorial. Okay, but an easier way to remember it is if you have to do the combination of taken 3. Start with the number 7, 6, 5, stop when you have that many factors. So there's 3 factors, 7 times 6 times 5. That's actually what this n minus r factorial does, is cancel out the 4, 3, 2, 1 in the numerator. And then divide by 3 factorial, 3 times 4, these cancel, 35. And that's the same number we got on the previous board. Now, if we want to answer the question, 2 men and 1 woman, well, if I have 3 men to pick from, and I want to take 2 of them, this is a symbol for the number of possible outcomes. And here's a list, AB, AC, BC. So there's 3 of them. And if I actually do that calculation, combination of 3 things taken 2 at a time, that's 3 times 2 over 2 factorial, or 2 times 1, 3. And here's the combination of 4 things taken 1 at a time. The answer is 4. And if I want to make committees out of these combinations, I can pair AB with D, E, F, or G. And I can compare join AC with D, E, F, or G, and so on. So the way to do that possible outcomes is 3 times 4, actually. That's called the fundamental counting principle. And that gives us the 12 that we see listed down here. Combination of 4 things taken 1 at a time is 4. Okay, so that's the idea. Now, if we go back to here and try to follow the same pattern, if you try to list out all the possibilities, you'll be here for the rest of your life. Okay, that's why we need this combination formula. So we first have to figure out what are the total possible number of outcomes. Well, there's 24, 34, 43 people to pick from. And we want to take 12 of them. So whatever that number is, and it's huge, that's the denominator of the probability. Now, if we want all men, that means we've got 19 men to pick from, and we're going to take 12 of them. And the number of women will be 24 taken 0 at a time. And the combination of 24 things, when that number is a 0, this evaluates to 1. So it's the combination of 19 things taken 12 at a time in the numerator. For all women, it will be the combination of 19 things taken 0 at a time times the combination of 24 things or items taken 12 at a time, all over combination of 43, 12. Of course, you can use a calculator to do this. 8 men, 4 women. Well, for the possible combinations of men, you've got 19 to pick from. You're going to take 8 of them. And then you compare that, each of those combinations, with the combination of 24 women taken 4 at a time. In other words, the 4 and the 8 add up to 12. And you put that over a combination of 43 taken 12 at a time. That's your probability. And I'll let you figure that one out. Okay. So if you go to Desmos and you want to type in this, for example, Desmos has a function that looks like this. You can actually type N capital CR, or you can go to the function menu and put in 19, 8. That's how you do it on Desmos. And so it would be times N CR 24, 4 divided by N CR 43, 12. Okay, hope that gave you some idea on how to do these. And if you have any questions, post a comment.